When you take the counting numbers, 1, 2, 3, 4, and so on, and you square them, you get what's called the perfect squares. 1, 4, 9, 16, 25, 36, and so on. You can keep going on as long as you'd like there. Now, we call these perfect squares because they are, well, a number squared. Not just any number, but a nice number to work with. Yeah. So, if you want to go the other direction, we use what's called a square root. It didn't exactly show up very nicely here, but a square root looks like this. The square root of 16 asks us the question, what number when squared gives us 16? And you can see clearly from up above, 4 squared gives us 16, which means the square root of 16 is 4. Similarly, you can answer the question, the square root of 36 is 6, because 6 squared equals 36. When you're looking at these, this is called a radical, that's what this symbol is. When you're looking at that symbol, or when you're looking at a square root like this, it does act as a grouping symbol. So this would be the same thing as having 9 plus 16 on the inside of the square root there, which means we would have to do that addition before I perform the square root. This works in much the same way that we saw with the division bar previously. So that means I would have to do 9 plus 16 first, which gives me 25. Now I could take the square root of 25, which would give me 5. This is as opposed to, a lot of people when they see something like this, the 9 and the 16, they want to take the square root of each of them. But let's see what happens when we do it that way. The square root of 9 is 3, the square root of 16 is 4, and 3 plus 4 is 7. You can see clearly we get a different number here. They're not equal to each other. So clearly we're not doing the same thing between those. So in this one, the addition was inside the square root. That's what this line over the top of it indicates kind of where it indicates where those parentheses are, if you want to think of it that way, or where your grouping symbols end. On this one, these parentheses, or these the line over these, will only extend over the one immediate number, and that's how I know that it's not going to be trying to do something else. If you can do something like this. You could do the square root of 9 plus the square root of 16, and this would do, well, okay, I would have to do the square root of 16 first, which would give me 9 plus 4 in here. Then I'd have the square root of 13. The square root of 13 is not a nice number to work with. So let's look to see how we would actually ask our calculator what number that is. On this calculator, my square root symbol is in yellow right here. It's kind of probably a little hard to see, but it's in yellow right there. If you're using the TI-36 calculator, the square root key is on your square key. It's actually the same thing as what's happening here. We have x squared, which normally if we did something like this, if I wanted to do 4 squared, I could press 4 and then just that button to give me 4 squared. If I wanted to do the square root of 4, what I do is I have to press second and then this button, and that puts my little radical. On this calculator, it actually opens up parentheses because it doesn't do a line over the top. Some TI-83 calculators, it actually does a line over the top of it, but this is an older model, I guess. Oops. Let's go ahead and just say the square root of 4, close my parentheses, and the square root of 4 because the square root of 4 is 2 because 2 squared equals 4. And that's how we type that into the calculator. So I'm looking to get the square root of 13, which when I type that in here, I get 3.60555 whatever. So it's not a very nice number to work with, but you know, it's still we can use the calculator to approximate that number. Alright, something like the square root of 169, you might not know that one right offhand, so you might need to go to your calculator and ask it. I'm going to go ahead and do the square root of 169, press enter, and you can see that gives me 13. But 237, the square root of 237, when I do this, it gives me 15.3948. 3948 ... And in this example, it says to round to 3 significant digits. Remember, 3 significant digits are not counted the same as just saying 3 decimal places. 3 significant digits, that would be 1, 2, 3. This would be the 3rd significant digit, which means I'd have to cut it off here, so I would round this off to 15.4.